Hey guys, Terry here. Now, I don't know about you, but as a consultant, I enter environments all the time that require me to take a snapshot or take a look at what the actual network infrastructure is, because more often than not, when I get called on consulting jobs, what ends up happening, it's a network that I've never seen before. And that's one of the reasons that we're going to be going over this particular section in the context of the CCIE version 5 Routing and Switching View on Demand series. We're going to be talking about one of the most useful tools we have available to us, and that tool is Cisco Discovery Protocol. Cisco Discovery Protocol is going to be that go-to component that we're going to use in order to be able to verify what devices are connected to what devices inside of our infrastructure. And it's through the use of CDP that we can actually create a topology diagram that's going to support being able to understand exactly what our layer 2 topology looks like. Now, the main thing that we want to understand here is that layer 2 is more about all of our physical interconnections. So if I want to decide or determine what switch a particular router is connected to, or which switches a particular switch is interconnected to with the purposes of its trunk links, what I can do is I can use CDP in order to be able to make that discovery. Now, Cisco Discovery Protocol is extremely handy, and one of the reasons it is so handy is the simple fact that it's media and network protocol independent. Now, that's not meant to say that CDP is going to run on every possible interface that we have, but one of the interfaces that it doesn't run on is a frame relay multipoint, and since frame relay is not inside the scope of the CCIE version lab exam anymore, we're not even going to really worry about that. So of the interfaces that we have, serial interfaces and Ethernet interfaces, it's important for us to realize out of the gate that CDP is going to be operational and functional on those interfaces by default. Now, when we go in and we start looking at this by the numbers, what we realize is that CDP operates at layer 2. Its primary purpose is to give us the ability to be able to learn about directly connected devices that we are actually hooked up to. So, like I said, if I have R1 and I have a logical drawing where I have a connection between R1 and R3 using interface 00, what I may actually have is R1 may be connected directly to SW1 via interface 00, and SW1 or CAT1 may be connected to SW2, SW3, and then connected to R3 via Fast Ethernet 00. Now, what I'm illustrating here is the principal difference between a layer 2 physical drawing and a logical drawing. The logical drawing, for all intents and purposes, remember, inside the confines of our switching environment, we're using transparent bridging. So the switches really don't come into play when it comes to our layer 3 protocols. We can just simply ignore them. But the main thing that we need to understand here is that when it goes to moving cables, and we're working at layer 2, we need to know what is connected to what so that we can actually create this drawing like what I've illustrated. And one of the main tools that we have available to us to be able to do that is CDP. Cisco Discovery Protocol actually allows this process of being able to discover our physical topology, and it allows us to do that by giving us the ability to discover the identity of our neighbors, determine how they're connected, because what's going to happen is a CDP is going to exchange information about particular interface types, particular versions of the iOS. All of that's going to be incorporated because CDP is optimized to operate using something called a TLV, a type length value. TLVs give us the ability to be able to construct a protocol that has the capability of having the modifications put in place to support different informations. So, as we are going to find out, we've taken CDP from its original version 1 to version 2 with some optimizations that allow us to be able to do things like mismatch detections, error configuration detections, and things along those lines in an automated fashion. And it's been able to do that because it's been enhanced to support this idea of TLVs. We'll talk more about that shortly. But the other part here is that the key element here is this all takes place even if we have different network layer protocols. That's the main payoff when it comes to working with a protocol like CDP, because CDP allows us to very quickly discover the nature of that infrastructure and all of these interconnections between our devices. But there are some prerequisites. So first of all, what we have to understand is that we need this idea of SNAP, Subnetwork Access Protocol. Subnetwork Access Protocol is the driving protocol, the enabling protocol that allows CDP to operate. Now, when we go in and look at our diagnostics section, when we're talking about the actual configuration and working with the CDP in the equipment, we're going to find that there's going to be some key pieces of information that we're going to highlight here in our theoretical conversation that we're going to see again. And one of them is going to be this idea of SNAP headers. Now, the other part of this here is we also have to recognize that CDP is Cisco proprietary. In fact, what we're going to find is that it's Cisco proprietary, but it was so useful that the industry standards body decided that they were going to make their own version of a protocol called Link Local Discovery Protocol, which we're going to be talking about in the next lesson. And they wanted to utilize it because CDP was such a powerful tool. Now, what we're going to also find out in our conversation is there's going to be, I guess the best word is what I call entanglement. Because Cisco Discovery Protocol is going to work with other features, capabilities, and protocols in the confines of our switching and routing environments. Now, what do I mean by that? Well, what we're going to do is when we start talking about trunks, we're going to find out that CDP is going to be working in unison with our dynamic trunk negotiation mechanisms. It's going to allow us to exchange information. CDP is entangled with a concept called the native VLAN, traffic in an 802.1 environment that is untagged. And since it's untagged, we need some mechanism to make certain that the native VLAN is the same on both ends of a link. And that responsibility falls in the confines of CDP. Also, later on in our conversations, we're going to talk about something called VTP, VLAN Trunking Protocol. We're going to find the information that is going to be critical if we're going to create dynamic trunks again in a VTP-enabled environment. We're going to have, again, this entanglement with CDP. So I want to discuss it now so that we understand it. And when it comes time to look at it in the context of all of these other elements, we'll already have a sense of vague familiarity with what it is that we're discussing. But by the simple fact that CDP is Cisco proprietary, keep in mind it's only going to be running on Cisco devices. And when we are going to be operating in an environment, we need to understand that Cisco to Cisco is never really going to be problematic. But what happens if I have another device? Well, Cisco also supports that concept of the industry standards protocol called LLDP that I mentioned previously. And we'll talk about that in the confines of the next lesson. But what I want to do right now is I want to highlight one point of entanglement. So think of this as the primer for VTP. When it comes to VLAN trunking protocol, we want to make certain that we understand what's happening and how this protocol is operating or entangled with the CDP. Now, VLAN trunking protocol, quite simply put, is just a dynamic method or mechanism that I can configure on Cisco devices. Again, it's Cisco proprietary, whereby I can create VLANs on one switch and have those VLANs being propagated to all other switches inside of what's referred to as a VTP domain. Now, I just want to scratch the surface on this. Now, what I want everyone to understand right now is that the VTP domain information is exchanged via CDP. So when we come through here, this management domain, the VLAN domain, or the VTP domain, is going to be actually communicated inside of my CDP messages. And we'll see that when we look at the configuration. But beyond that, what we're going to recognize is it's going to send information about the VLANs, something about the revision number, which is going to be the value that we're going to assign to a given database on a given device. The higher the revision number, the more believable the information is. Lastly, it's going to communicate those VLANs. So if I have 100 VLANs on one machine, rather than having to go to every individual switch in my infrastructure and doing the same configuration where I may make a fat finger mistake, I can rely on something like VTP to propagate it. Now, we'll talk about the nuances, the problems, and the issues associated with VTP in VTP section. But like I said, what we want to point out here is that we have this direct entanglement with CDP. Because again, information is going to be exchanged between devices using the CDP protocol. The Cisco Discovery Protocol is one of the most useful layer 2 tools that we have available to us, and one of the reasons it's so useful is the fact that it can communicate so much information, and it has the capacity to be modified to communicate different information in the future. This capability comes in the form of these TLVs that I was talking about, type length values. So think of it almost as the capability to have a variable payload that's going to that can be embedded in our CDP message exchanges. Now, we'll talk about some of the messages that are going to be communicated, but before we do that, I want to look at this method. I want to look at this VLAN methodology, because what ends up happening is TLVs, type length values, are actually going to be blocks of information, and we can embed those blocks of information into our CDP advertisements. These CDP advertisements are going to be layer 2 frames that are going to be exchanged between devices in a link local fashion. Now, the important thing to understand here is that any time I use the term link local, that means that those communications are actually going to be bounded to an actual physical segment. We're not going to do anything like forward them or route them to other segments. So the communications that take place between devices are going to be relative and specific to the individual segments. So what we're going to find is when we get into the demonstration of this is not only can we type a command like show CDP neighbors, where it's going to give us an individual listing of all of the connections that we have learned via CDP on a given device, we can even target it down to an individual interface. Remember, I mentioned previously that when it comes to Cisco switches, almost everything that we talk about is either going to be configured or driven at an interface basis by interface basis. So recognizing what's going on here, these TLVs allow us to be able to vary the payload in our messages. And again, it's enabling us simply through this concept of TLV to be able to enhance the protocol for future use. It is extremely extensible because of the fact that we're using these TLVs in order to be able to control the nature of our payload. So when we go in and we start looking at this, exactly what is it that we're communicating? Well, let's look at that. Now, this is not by any stretch of the imagination meant to be completely inclusive. So let's just say it's partially inclusive. So I'm not covering everything that's going to be communicated. Why do that when we can actually look at a CDP frame using our packet sniffer and be able to look at exactly what's going to be inbound in the payload? And that's what we're going to do after we get finished with our theoretical discussion. But recognize the fact that it's going to exchange information about iOS. What version of iOS is my neighbor running? It's going to give me the nature of that particular device. Is it a 2900? Is it an 1800? Is it a 2811? What particular type of hardware platform is it that I'm connected to? Because that could also be significant. We have platform issues. We have platform bug related problems. So looking at that and knowing it, again, it's going to be CDP that can give me that information. And also bear in mind that I can get information for devices that are not physically located in the same site I am, as long as they support the SNAP headers. Now, the other part is it's going to give me IP addresses. So again, very, very handy to be able to do these discoveries, to build these drawings so that I can actually extrapolate some graphical representation of what my network looks like. Now, the other part of this is that it's going to give me all of my locally connected devices that are running CDP. Because what we're going to find here is the moment that CDP is enabled, and it's on by default to be perfectly honest, the moment that it starts running, it's going to be listening to a particular MAC address, and it's going to be sending information to a particular MAC address. Through this idea of listening and sending to these layer 2 addresses that are specifically built for the purposes of allowing Cisco to operate, Cisco's Discovery Protocol to operate what's referred to as a well-known multicast address, we can exchange all of this information to include things about higher layer information like IP addresses. Remember, CDP is a layer 2 protocol, but exchange information about the associated layer 3 configurations as it applies to both IPv4 and IPv6. Now, the other part of this is that it tells us anything about our active interfaces as well as their encapsulation type. Very, very important if I'm connected to a particular type of link, serial versus Ethernet. Now, in a virtualization environment, keep in mind, in the lab, you're still going to have serial interfaces. So if you're doing your labs and you decide to go with the CSR the cloud services router, the 1000V, everything's going to be great and wonderful, but keep in mind you're still going to have to do some work and focus on serial connections. I don't want you to be surprised when you get into the lab and you actually see serial interface connections on your devices. So again, it's going to be through the use of Cisco Discovery Protocol that we're going to have the capability of identifying encapsulation types, and we'll talk about those. I mean, on serial we have PPP, we have HDLC, and a number of other elements. It's going to give me information about host names, duplex settings on my interfaces. We'll talk about the direct impact, well actually all the way in CCNA and CCNP we were talking about the direct impact of duplex mismatch issues. And two other elements that were going to become very, very germane to us in the next couple of videos, and that's going to be this idea of the VTP domain and our native VLAN. Because the native VLAN can be configured on each device independent. There's no exchange. I can go to switch 1 and say the native VLAN is X. I could go to switch 6 as long as we're connected on a link and say the native VLAN is Y, and what's going to end up happening is there would be mismatch that would allow something called VLAN hopping. To prevent that, what they've done is they've modified CDP to discover that mismatch, and also there's another protocol that we're going to be talking about later on in this particular series that's going to be called Spanning Tree Protocol, and Spanning Tree Protocol is going to detect that mismatch and it's going to bring those ports down into inconsistent state. And again, this is all stuff that we'll actually view and observe when the time comes. Now, how does CDP operate? Well, remember, I mentioned that we have a multicast address. That well-known multicast address is going to be this value right here, 10000C, CC, CC, CC. Now, what's going to happen at this particular juncture is that we're going to start sending periodic advertisements to this particular multicast address. And again, this is a multicast link local address. So these are never going to be forwarded. Now, the main thing is what we have to recognize is that we have a hello time and we have a expiration time. Now, by default, my hellos are going to be every 60 seconds. My expiration time is going to be 3 times my hello. So what's going to happen is this. I will be able to expect to receive hellos from my neighbor on a fixed interval. By default, that interval is 60 seconds. We can change it, and we'll talk about that in the demonstration. Now, if I miss a hello, that's not a problem. If I miss a second hello, that's not a problem. If I miss a third hello, we've got a problem. And what's going to happen is that I'm going to remove information from my CDP table. Yes, there's a CDP table. So that tells us one thing and one thing only, and that is that CDP maintains stateful information. That stateful information relies on these timers in order to determine whether or not that information is valid or invalid. So keep in mind, by default it's 60 seconds for my hellos, which means I'm going to be sending those multicast hello messages out to that MAC address that you see directly above my head. And what's going to happen is if I miss 3 of those, so after 180 seconds, if I have not received something from my neighbor, what I'm going to do is I'm actually going to expire the information that I learned from that neighbor from my CDP table. Now, this idea of sending and receiving information is how we maintain a concept of FSM, our finite state machine. A finite state machine mechanism is going to be how we manifest one understanding, and that is that we cannot expect in any networking environment for an adjacency to a neighbor to constantly stay up. We have to recognize the fact that power outage, hardware issues, misconfiguration, backhoes cutting cables, we have the capability and the probability that the neighbor is at some point going to go down. Well, the finite state machine recognizes the fact that if something is finite, that means it has to have a fixed value. So it's not going to be infinitely up. So we need some type of mechanism to determine whether or not these communications, or that these peerings are going to be up, and determine when they fall as quickly as humanly possible. Well, not necessarily as quickly as humanly possible, but we want to make certain that we do the discovery that we've lost our links, and we want to be able to do it efficiently. Now, what we have to understand is on slow links, like serial connections, sometimes we run into a problem if we go in and we start changing these timers, because it does take longer for information to be serialized and placed on a wire on a serial connection. So recognizing that, sometimes it is possible for us to amp up our timers a little bit too aggressive, and we can run into problems. Which is why more often than not, I recommend that you use the actual default configurations. Now, the only time you would ever go in and manipulate any of these CDP timers and affect the CDP finite state machine, what you're going to do is it's going to be because you receive direct instructions in the lab to do it. Unless you're told to change anything, leave it the way it is. So, I mean, that's hard and fast advice. Yes, you can go in and you can change it, and Cisco says they're not going to penalize you for extra configuration in the configuration section of the lab. However, if you change it wrong and you mess up your timers and you do have some type of communication problems where links start flapping, then you can run into issues where it may cost you points. So never do any voluntary configuration in the context of the actual lab. Now, when we go through here, the other main element to this, possibly the biggest benefit is that we're now going to rely on this information and we're going to treat it like heartbeats. So these heartbeats, these hello messages are going to be exchanged, and they're going to be exchanged on that 60, 180 second frame, to where if I miss 3 of these, then I'm going to bring the link down, and I'm going to actually expire any information that I have in my CDP table. And we do that for the sole and express purposes to learn that when interfaces on other devices go up or when they go down. So again, keep in mind it's going to be CDP that's going to enable my infrastructure and my environment to better detect and allow me to recognize the fact that I have or that failures exist in my infrastructure. Now, in CCNA version 5, in CCIE routing and switching version 5, we are going to be looking at everything from the point of view of IPv4 and from IPv6. CDP is absolutely no different. CDP allows me to operate and work with IPv6. Now, we're going to see IPv6 more and more in the real world, and we're also going to have to understand it in the context of the lab. So in future presentations, when we start talking about EIGRP, OSPF, RIP, we're going to also be talking about the IPv6 flavors of each of those protocols. So gone are the days where we really just could kind of take IPv6 for granted, and Cisco's recognizing that, and what they're doing is they're making certain that we understand in the context of the lab how IPv6 can help us, how it can hinder us, and how we can get around many of the issues that we may inherit the moment we start working with the protocol. Now, the main thing is this, and this is the easiest part. It offers the exact same benefits that we have with IPv4. Now, it does it in the same fashion because, again, we have the capability of supporting these TLVs. So the information that's being exchanged can be related to IPv4 or IPv6 because CDP, by its very nature, is going to be protocol independent, or another term that I like to use is agnostic. So it doesn't really care. Now again, what we're going to do is we did make enhancements to CDP in order to have CDP support IPv6. And it's important for us to note that we have CDP version 1 and CDP version 2. In the confines of our configurations in version 5, CDP version 2 is going to be the go-to tool that we're going to have. It's going to be version 2 by default, because version 2 has optimizations for that link failure detection and optimization, and it also better supports this notion of IPv6. Now, when we start going through this and we start understanding what's happening, it gives us the exact same key benefits as it did in IPv4. In IPv6, it's going to allow us to manage our network environments, because keep in mind, CDP has a direct correlation to almost every protocol that we're going to be talking about in some shape, fashion, or form or other. When it comes time for us to talk about things like our IP services, our iOS management utilities, things like Simple Network Management Protocol, what we're going to find is there's going to be CDP MIBs that are going to be these database entries that are going to correspond to pieces of information that we can actually learn and discover through CDP. So again, constantly think about this because it's extremely important. CDP is something that we take for granted, but it's going to actually be related to almost everything that we're going to be talking about in the future. And it's going to be through this idea of entanglement that I discussed. Now, when we go through, again, keep in mind, CDP also allows us to exchange information about our IPv6 and our neighbor address information. So it's no different than IPv4. And once we have this, it's also important that it's going to be an integral troubleshooting tool. As it is in IPv4, as it is when we're troubleshooting or we're starting to try to look at our layer 2 environments. So it's not only just a point of view from troubleshooting, it's also from a point of view of a tool that we can use for discovery. Because keep in mind, we have to be able to divine what our layer 2 environment is. Now, at the end of the day, really and truly, what does it boil down to? Well, it boils down to the simple fact that we have more than a handful of benefits associated with CDP. So these benefits include, it allows our systems using different network layer protocols. So we can operate with different layer 3 protocols, but we're able to exchange information at layer 2 about those protocols. And again, we'll take a look at that. So it allows me to discover about one another irregardless of the layer 3 protocol that we're running, or the networking protocol. It also allows us to facilitate the management of these devices. So again, it does this because it allows me to discover them, and not only can I discover the identity of my neighbor, I'm going to learn how my neighbor is configured. IP addresses, layer 3 information, any of that information, layer 3 information including IPv6. And again, all made possible through this idea of TLVs, type link values. Let me write that in a little bit better, TLV. So again, keep in mind, TLVs are really important because we're exchanging information, and since CDP exchanges information using those TLVs, it's also going to be very useful for us if we find ourselves in situations where we need to troubleshoot message formats that utilize TLVs. Now, lastly, like I mentioned previously, we have this idea of an integration with SNMP, Simple Network Management Protocol. And what we're going to realize here is for all of these pieces of information that we can learn or exchange using CDP, we have a corresponding database object in the confines of SNMP that we can use for the purposes of sorting and determining particular actions or monitoring particular results with regard to CDP information exchange, so that we can fire off a trap or an inform and send it to a server that's going to allow us to be able to focus on the particular element that we're looking at. And it's going to be, again, through that idea of the management information-based connection that's going to enable that process. So don't lose sight of the fact that CDP is an extremely handy tool, and it's also going to be not just a tool for troubleshooting, it's also going to be a tool for fault detection. So with that being said, what I want to do now is, as we've finished the theoretical component, let's dive right into the lab in the next video. I'll see you guys there. Bye-bye.